Imagine you're standing on the sidelines, maybe watching a youth soccer match. You see these incredible young athletes just full of energy, right?
Yeah, definitely.
But you're also aware, maybe keenly aware, that their bodies are still growing, changing so much.
Mm-hmm.
And if you're a coach or a parent, maybe even a player yourself, you're always trying to figure out, the best way to train.
Right. How to optimize things.
Exactly. How do you develop skills, build strength, but without pushing too hard or maybe too soon? Is there like one perfect training plan for everyone?
Well, that's the big question, isn't it?
Or does their own individual biological development stage matter? Well, way more than we usually think.
Uh-huh.
Okay, so let's unpack this. This deep dive is all about understanding exactly how a young athlete's biological maturity influences how effective their training programs actually are.
Right. Does the timing matter?
Yeah. We're kind of on a mission today to pull out those surprising nuggets, the bits of knowledge that could genuinely change how we approach youth sports, moving beyond just generic drills to something more tailored, more impactful.
Makes sense.
And for this mission, we've gone deep into some really cutting-edge research. Our main source today is this fascinating article titled, "Can Maturation Level Influence Long-Term Physiological and Physical Adaptations in Youth Female Soccer Players Exposed to Combined-Sided Games and HIIT, a Comparison Across Maturation Statuses?"
Okay, quite a title.
It is. It's by Ying, Zhou, Jing, Liuxi, Yang, and Bosong, Zheng. Published online September 1st, 2025 in the Journal of Sports Science and Medicine, Volume 24.
Got it. Journal of Sports Science and Medicine.
Yeah. And our goal here is really to break down this important research, make it scientifically clear, but also, accessible and practical for you, the listener, especially if you're curious about optimizing performance in these developing athletes.
Sounds good. Let's dive in.
All right. So, to set the stage, let's quickly define the two main training methods the study looked at. High-intensity interval training, HIIT, and small-sided games, or SSGs.
Okay. Common terms in soccer training.
Right. HIIT, well, the name kind of says it all. Short, sharp bursts of really intense exercise, then brief recovery. Think of it as like a powerhouse for boosting endurance and just raw sprintability.
Yeah, those hard efforts.
And SSGs.
Yeah.
Those are the scaled-down games, maybe 2-on-2, 3-on-3, smaller pitch, brilliant for game-specific skills, tactics, and also those physical things like quick accelerations, decelerations.
Things you do constantly in a match.
Exactly.
Yeah.
And the beauty is these two often get combined. HIIT builds the engine, maybe, and SSGs help translate that into, game performance.
And what's truly fascinating here, and really what the study comes down to, is how those training methods interact with a critical biological factor, maturation.
Okay.
When we talk about maturation in youth sports, we're not just talking about chronological age, like how many birthdays they've had.
Right, not just the number.
No, we're focused on their biological development. How far along are they in their growth spurt? This study zeroes in on something called peak height velocity, or PHV.
PHV, peak high velocity. Okay.
Yeah, that's that unique period in adolescence when someone has their fastest rate of growth. They literally shoot up. It's a really important biological marker. And athletes get classified based on where they are relative to it. Pre-PHV, meaning they're approaching that spurt, mid-PHV, right in the thick of it, and post-PHV, meaning they're past that rapid growth phase.
So the idea is like a 12-year-old who hasn't hit their growth spurt yet might respond totally differently to training than another 12-year-old who's maybe already finished theirs. Is that the kind of thing we're talking about?
Exactly that. It's that individual biological clock, not just the calendar age, that seems to dictate how their body responds.
Wow.
And this is really relevant because, honestly, previous research on how maturation impacts training responses, well, it's had some conflicting findings.
All right.
Yeah. Some studies suggested maturation didn't have much impact on, say, intensity during small-sided games. Like, all kids respond the same. But others showed strong links between maturation and training intensity, or even match performance. These differences might just be down to, different study designs or how they measured maturity.
Okay.
Which is why this current study is so valuable. It's trying to clarify some of that fuzziness with a very specific training program.
That makes perfect sense. So for you listening, maybe you're a coach trying to get the best out of your team, or a parent navigating this, or even an athlete. What's the big takeaway here about this idea of individualized training based on maturity?
Well, it really means these developmental changes mean we need highly individualized training. The same training stimulus, the same drill, the same intensity could give you wildly different results depending on where an athlete is on their maturation journey.
Mm-hmm.
And it's not just about effectiveness, it's also really about safety. An approach that's perfectly safe and super effective for a post-PHV athlete whose body is more mature might be less effective or maybe even risky for someone who's pre-PHV. It
Right.
really challenges that common practice of just, one-size-fits-all training for a whole age group.
Wow, that's a profound thought. It means we might be missing huge opportunities or even causing issues if we don't factor this in. So, okay, with all that background, what did these researchers actually do? How did they set up the study?
Right, let's get into the nuts and bolts.
Yeah, let's peek behind the curtain. They gathered 54 female soccer players, aged between 9 and 16. And crucially, every single one had at least a year of consistent soccer experience, so not total beginners.
Okay, so they knew the game.
Exactly. These players were then carefully categorized into those 3 maturity groups we talked about, pre-PHV, mid-PHV, and post-PHV. They used a specific formula looking at age, height, sitting height, body mass.
A standard method for estimating PHV status.
Right. Once categorized, they were randomly assigned, either to an intervention group, 27 players doing the combined HIIT and SSG training, or a control group, also 27 players, who just carried on with their regular team training, kind of like a baseline.
Okay, standard randomized control trial design.
Yeah. And how did this specialized intervention group train? What did those extra sessions actually involve?
Good question. The HIIT and SSG group did 2 extra training sessions each week.
Okay, additional work.
Yep. Scheduled on non-consecutive days, and importantly, these sessions happened before their regular team training, so it was supplemental.
Got it.
Each session was pretty well structured. It included 2v2 small-sided games played on a 20 by 15 meter pitch, focusing on those game-specific movements, decisions.
Right, the game-like stuff.
Exactly. And then after the SSGs, the players did individualized high-intensity runs.
Okay, and when you say individualized high-intensity runs, what did that actually look like? How did they tailor it?
Ah, that's a key detail. These weren't just random sprints. The intensity was precisely set for each player based on their own fitness level.
Okay.
It was set at 85% of their final velocity during the 30-15 intermittent fitness test, the VIFT.
Ah, the VIFT score.
Yeah. So if player A was faster on that test than player B, her 85% target speed would be higher. It ensures the intensity was genuinely appropriate and challenging for her specific fitness.
Smart.
And the whole program was progressive, meaning the volume and intensity gradually increased over the 6 weeks. Just standard practice to keep challenging them.
Okay, makes sense. So they tracked them over 6 weeks. What exactly were they measuring to see if this extra training actually made a difference?
Right, the outcomes. Before and after the 6 weeks, they put the players through a few physical fitness tests.
Okay.
They measured isometric mid-thigh pull, or IMTP. That's basically a test for maximal lower body strength. How hard can you push statically?
Gotcha. Max strength.
Then 30-meter sprint time. Pretty straightforward, assesses dynamic sprint performance, just raw speed.
Speed.
And finally, that 30-15 intermittent fitness test, the VIFT again. This measures aerobic capacity and that intermittent endurance, which is so crucial for soccer's stop-start nature.
Right, that ability to keep going, recover quickly.
Exactly. So those 3 measures, strength, speed, and intermittent endurance, give a pretty good picture of physical fitness for soccer.
Okay, we've covered the setup. Now, the moment we've been waiting for, what did they actually find? Let's get into the results, starting with strength. And if we connect this back to the bigger picture, these findings really tell us a lot about tailored training, don't they?
They absolutely do. The results for maximal strength using that IMTP test are particularly, illuminating.
Okay.
Overall, the HIIT and SSG group showed significant strength improvements compared to the control group. Big effect size, too, meaning the training had a real substantial impact.
Good start. The training worked.
Yes, but here's the kicker and maybe the shocker for some coaches. When you break it down by maturation, the most substantial advantages in strength for that HIIT and SSG group we're seeing in the mid-PHV and post-PHV athletes.
The ones in or past their growth spurt.
Exactly. They showed significantly higher strength after the training compared to the controls in their same maturity group. But for the pre-PHV athletes, the youngest, least mature players, there was basically no significant difference in strength gains between the trained group and the control group.
Whoa, okay, hold on. So if I'm coaching younger players, say under 11 or 12 maybe, That intensive strength work they did just wasn't really moving the needle for their actual strength development compared to just regular training.
That seems to be what this study suggests, yes. It's a huge insight.
Why? Why would that be?
Well, the thinking is, and research supports this, that strength increases in pre-PHV kids are mainly driven by neural adaptations.
Neural, like brain-muscle connection.
Exactly. Their brains get better at telling their muscles to fire more effectively. They learn coordination, activating existing muscle fibers better. It's more about efficiency.
Okay.
But during mid and post-PHV stages, you get those big hormonal changes, increases in testosterone, growth hormone, IGF-1.
Right, the hormones associated with growth and development.
Precisely. Those hormonal shifts provide the biological backup, if you like, for more obvious muscle development, actual increases in muscle size, and so bigger strength gains from training. The HIIT gives a strong neuromuscular stimulus, and those explosive actions in SSGs like jumping and landing, accelerating, decelerating, they also contribute, especially when the body, hormonally, is ready for it.
That distinction, neural versus hormonal adaptation, that's really key. It suggests we might be pushing strength training on younger athletes when their bodies just aren't biologically set up to respond with big gains yet.
That's certainly a major implication.
Okay, what about speed then? The 30-meter sprint, did that follow the same pattern?
Okay, sprint performance, measured by the 30-meter sprint. Here, the maturity differences were, if anything, even more pronounced. Again, overall, the HIIT and SSG group got faster, significant improvements, fantastic. And it's a big, but only the post-PHV athletes in the training group showed significantly faster sprint times compared to their control group counterparts.
Only the most mature group saw that distinct speed advantage from the training.
That's what this data showed, yes. The pre-PHV and mid-PHV groups, well, they might have improved a bit generally, but they didn't show that same clear separation from their control groups that the post-PHV athletes did.
So even with specific speed work mixed in, the younger groups just didn't get significantly faster relative to their peers who were just doing regular training.
Precisely. Now, sprint speed can improve at any stage, often through better technique, better coordination, that neural adaptation again.
Right. Running form mechanics.
Exactly. But these more pronounced benefits later on, that's really interesting. One potential reason is increased myelination of motor neurons.
Myelination, what's that?
Think of it like insulating the electrical wires in your nervous system. Myelin is a fatty sheath that wraps around nerve fibers.
Okay.
And this process tends to happen more through late adolescence. Better insulation means faster, more efficient nerve signals. And that's absolutely vital for the super rapid, coordinated muscle contractions you need for sprinting.
So until that biological insulation is more complete, the ability to significantly boost raw speed through this kind of training might be limited.
That could well be part of the explanation, yes. It points again to biological readiness.
Fascinating detail about myelination. Really drives home that point. Okay, third area, aerobic capacity. The VIFT test, same pattern or something different here?
All right, finally, let's look at aerobic capacity from the VIFT results. Here, again, significant improvements for the HIIT and SSG group compared to controls. Another strong overall effect.
Okay, so the training helped fitness overall.
Yes, but here's the crucial difference compared to strength and speed. These improvements in aerobic capacity. They were seen across all three maturation stages, pre-PHV, mid-PHV, and post-PHV. All showed significant gains compared to their respective control groups.
Oh, okay, so unlike strength and speed, where the big benefits were really for the more mature athletes, aerobic fitness seemed to improve significantly for everyone, regardless of where they were in their growth spurt.
That's exactly what this study found.
Does that mean we can sort of push fitness earlier on with maybe less concern about maturity compared to strength or pure speed work?
That's a great question, and it's certainly what this data suggests for this specific type of combined HIIT and SSG training. This consistency across the group suggests this program works well for enhancing intermittent running performance, no matter the athlete's biological maturity.
Why the difference, though? Why aerobic but not strength or speed so much early on?
Well, generally speaking, aerobic capacity remains quite adaptable throughout childhood and adolescence. The systems involved just seem more responsive to training earlier on.
Okay.
And both parts of the training contribute here. HIIT is known to improve things like maximal oxygen uptake, your VO2 max, and anaerobic threshold. And SSGs, while they naturally mimic those high-intensity stop-start demands of a match, constantly challenging that intermittent endurance.
Right, so both training methods hit that aerobic system effectively, regardless of maturity.
It seems so, making it perhaps a more universal benefit of this kind of training for young athletes compared to the more maturity-dependent strength and speed gains.
Okay, this is all really fascinating science. But if you're listening, maybe as a coach or a parent, you're probably thinking, all right, what do I actually do with this? Let's pull it all together. What does this mean for how you might train young female soccer players? What are the practical takeaways?
Yeah, that's the key question, isn't it? How do we apply this? The research really points strongly towards needing individualized training. It's not enough to just group by age.
Right.
Coaches absolutely should think about integrating both structured, individualized HII and small-sided games into their training for young female players. They both offer benefits.
Okay, so do both, but maybe differently.
Exactly. It's about adjusting the emphasis based on maturity.
Okay. How so?
Well, for your post-PhD athletes, the ones past their main growth spurt, you might want to prioritize HII a bit more if you're specifically targeting maximal strength and aerobic capacity improvements. Their bodies seem most ready to make big gains there from that kind of stimulus.
Right. Lean into what they're ready for.
Yep. Now, for your pre- and mid-PhD athletes, while they'll still get those aerobic benefits, perhaps the emphasis should shift more towards the SSGs.
Why SSGs for the younger ones?
Because SSGs are fantastic for developing tactical understanding, game-specific fitness through all those little bursts and changes of direction, and really crucial foundational movement skills, things like coordination, agility, reacting to the game.
Got it. So focus more on skill and game understanding through SSGs while still getting some fitness benefits for the less mature players.
Precisely. It's about building that robust athletic base, developing the skills without necessarily forcing strength or speed adaptations their bodies might not be fully ready for yet. This kind of tailored approach helps target training better, supports overall fitness and technical strategic development, hopefully reducing risks like burnout or injury from loading them inappropriately.
So tailoring the focus makes a lot of sense. But just playing devil's advocate, if post-PhD athletes are primed for strength gains, does that mean we should only focus on that? Any risks to over-specializing? And what about the study's own limitations? We should probably touch on those.
Oh, absolutely. That's an excellent point about specialization. While the study highlights these optimal windows, it definitely doesn't mean you should only do strength work with post-PhD players. Youth development is still about building a well-rounded athlete.
Right. Broad base first.
Always. The findings simply suggest that if strength is a specific goal, the later stages show more response to this type of HSG training stimulus. And yes, limitations, every study has them. This one was relatively short, only 6 weeks. That might not capture the full picture of long-term adaptations.
Okay.
It also didn't explicitly control for recovery between sessions, which can always influence results. There's also just inherent variability in small-sided games. The intensity can fluctuate based on players, opponents, etc. Makes standardizing the dose a bit tricky sometimes.
Right. Not as controlled as a set run, maybe.
Exactly. And because players came from multiple teams, their regular team training outside the study could have added some variability the researchers couldn't fully control.
Fair points.
Which naturally leads to the call for future research. We need longer-term studies, longitudinal ones, to track these kids over time. And studies looking specifically at dose response like, what's the optimal amount or intensity of training for a pre-PhD kid versus a post-PhD kid to get the best results in strength or speed or fitness? We still need more detail there.
Yeah. More research is always needed. But this study, it really highlights the incredible complexity, doesn't it? The growing body, how different systems respond to training at different times.
It really does.
It kind of makes you wonder, beyond just soccer, what other activities or skills might have these optimal windows for development, things we should be more aware of as learners, whether it's, I don't know, music or language, or even certain thinking skills.
That's a great thought. The idea of biological readiness probably applies much more broadly than we often consider.
Definitely something to mull over. Now, if you, the listener, are eager to really dig into the data, see the tables, the figures, read the full discussion yourself.
Which is always recommended if you're really interested.
Absolutely. You can find the complete article by Ying Zhou, Jing Liu, Liuxi Yang, and Bosong Zheng. Again, the title is, Can Maturation Level Influence Long-Term Physiological and Physical Adaptations in Youth Female Soccer Players Exposed to Combined-Sided Games and HIIT? A comparison across maturation statuses. It's in the Journal of Sports Science and Medicine, Volume 24, pages 634 to 644.
Worth a read for coaches and practitioners in youth sport.
For sure. Well, thank you for joining us on this deep dive into youth athletic development. If you found this insightful, maybe useful, remember to follow our channel and turn on notifications so you don't miss any of our future explorations into fascinating topics.